So today we're going to talk about area of circles and sectors. So first, the area of a circle formula, which you probably remember from a previous class. The area formula is area is equal to pi r squared, where r is the radius. So you should have your calculator along with you as we go along with this. We want to find the area of a circle with a diameter of 1.8 inches. So our area formula, as we just said, is equal to pi r squared. But what's given to us is not the radius, but the diameter. So the diameter is equal to 2 radii. So if the diameter is 1.8, then that means that a radius is half that, which is going to be 0.9. So I can take that and I can plug it in. So my area is equal to pi times my radius, which is 0.9 quantity squared. And so then if I calculate that in my calculator, I am going to get approximately, area is approximately we'll round to the nearest hundredth, so 2.54 in this case, and that would be inches squared for the unit. Another thing we can do is we can find the radius of a circle given a certain area. So in number 2, we're going to use the same formula. So again, I'm going to write it down. Area is equal to pi r squared. And we want to find the radius, and we're given that the area is 65 square centimeters. So the 65 is going to go in for the A. So I have 65 is equal to pi r squared. So I'm going to solve for the radius. So I'm going to first divide by pi. So 65 divided by pi is equal to r squared. That pi canceling on the right hand side. And then to get rid of the square, I'm going to take a square root on both sides. And I'm going to cancel that. So my r is equal to the square root of 65 divided by pi. Now just be careful when you plug this into your calculator that you're actually dividing the 65 by pi first, and then you're taking the square root of it. So we should get that the radius is approximately 4.55, and this would just be centimeters because it's the length of the radius. Now on the VTP, we have a few things to fill in. First of all, what is a sector of a circle? So a sector of a circle is basically like a pizza slice of a pizza. So if I make 2 radii like that, it makes a circle. Or sorry, it makes a sector of a circle. And so that sector is going to be all of this area inside of those 2 radii that I drew on there. And so this sector of a circle is a region bounded by 2 radii and of the circle and their what we call is the intercepted arc. So the intercepted arc here is going to be this arc that's from the end point of each of the 2 radii. So that's the region that makes the sector of a circle. Like I said, it represents like a slice of pizza. So here we have this circle, and it says to name the sector ABC. So since B is in the middle, that's going to be the vertex. So I can let's say put point A here, put point B here, and put point C here. So that represents sector ABC. Now, if I want to find the area of the sector of a circle, it's very similar to the area of a triangle because it's simply part of the area of a circle. I think I just said triangle. So it's a part, which a part we know is a fraction. And we can find that fraction by using the central angle or the arc measure. So the area of a sector is going to be, so area is equal to, so this central angle here, if this arc has a measure of m, this central angle is also m degrees. So it's going to be the measure of the central angle divided by the whole distance around a circle, which in degrees is 360, multiplied by the area of a circle, which is just pi r squared. Now, this second one, we won't really use this one too often, but it says in radian. So the only thing that changes here is that if we have the angle in radian, then the area is going to be the measure of the angle. I'm going to put in radian right next to it so we know. And then instead of 360 for all the way around a circle, it's 2 pi all the way around a circle. And then times pi r squared. And so you can see here that every time the pi's are going to cancel out in that second formula. So if we try these two examples here, we want to find the area of the sector formed by angle PQR. So we're looking for the area of that shaded region. So starting off with my formula, the area is equal to the measure of the angle divided by 360 times pi r squared. And so what I have is I have 140 divided by 360 times pi times my radius squared. And sometimes people get confused with the simplifying with this 4 squared right here. I would expand it into a 4 times 4. So I'm going to do that so that when I reduce, I don't accidentally reduce too much. So 140 divided by 360 times pi times 4 times 4. And then I'm going to also put this all over 1 to keep my fraction all lined up. And so now I'm going to reduce what I can, so I can cancel out the zeros. And then I could reduce, let's see, I could reduce the 14 and the 36 more. So 2 goes into both of those, so this could become 18, and this could become 7. Then I could reduce the 18 with one of the 4s. So the 18 can become a 9, one of the 4s can become a 2. And I think that that's all. So then simplifying that, I end up with my area is equal to, we have 7 times pi times 2 times 4. So 7 times 4 is 28. 28 times 2 is 56. So 56 pi divided by my denominator is 9. And that's going to be centimeters squared. And if you wanted to find the decimal for that, you could plug it into your calculator and find the decimal. But we'll just leave it as an exact answer for right now. All right, number 7 is set up a little bit differently. It says to find the area of circle Y. So this one's interesting because we know that the area of the circle is going to be pi r squared. Now, the area of a sector, so I'm going to put area of a circle here, and then the area of a sector, we know is the measure divided by 360 times pi r squared. Now look at this right here. This pi r squared in purple, that's this whole thing. So really the area of a sector, get some more space here, is the measure of the angle divided by 360 times the area of a circle. So I'm just going to put in the area of the circle here. And that's what I want to find, is that area of the circle. So this is the area of the sector. Now look at what's given. We're given that the area of the sector is 4.1 square feet. So that goes in here. So I'll put 4.1 in on the left-hand side. So on the left-hand side in my yellow, I have 4.1 is equal to, let's see, the central angle there is 25, right? So we're looking at this central angle right here is 25. So 25, and then divided by 360, and then times the area of the circle. And I'm just trying to solve for the area of that circle. So if I want to do this in parts, I can multiply by 360 and then divide by 25, or I can simply multiply by 360 over 25. The 360s cancel, the 25s cancel. On this side, multiply by 360 divided by 25. And think about this as over 1. And then we can just plug that into our calculator. So the area of our circle is going to equal, so plugging it into the calculator, what we're plugging in is we're doing 360 times 4.1 in the numerator, put parentheses, and then divided by 25. And that area of the circle then is approximately 59.04. And the unit here would be feet squared. And there we have the area of our circle.